Welcome back to your favorite pre-calculus course. We're going to look at graphs of other trigonometric functions in this section. I'm going to go ahead and sketch the graphs of the tangent function, um, the cotangent function, some of those reciprocal functions, and take a look at some of the behavior of that. So let's go ahead and start out with our tangent function. Now, let's recall that the tangent is the same thing as the sine over cosine, right? Definition of the tangent there, sine over cosine. So if you're getting some points here, let's start out, let's plug in 0. You want to find the sine is 0 over the cosine is 0. Of course, the sine is 0 is 0, cosine of 0 is 1, so we end up with 0. Okay, so we got the point 0 comma 0 on the graph here. And let's think about what would make this thing undefined. So let's talk about some vertical asymptotes here. Okay, so we would have some vertical asymptotes wherever our denominator, wherever that cosine of x is equal to 0. So cosine of x equals 0. So where would that occur? So the cosine of what value is 0? I say, well, pi halves, isn't cosine of pi halves 0? No, pi halves, so x equals pi halves. Where's another one? How about 3 pi halves? Where's the next one? Well, if we go around the unit circle and pi halves more, we're going to end up with 5 pi halves, right? And so on. Where's the next one? It's going to be 7 pi halves and so on, okay? So you know you got those vertical asymptotes there. Well, and also, what about in the negative direction? You know, negative pi halves. What's the cosine of negative pi halves? You also got 0. What's the cosine of negative 3 pi halves, which is coterminal to pi halves? Cosine negative 3 pi halves is 0, and so on. Okay, so all of these you got to consider plus minus on this, okay? So if you want to, you could also state that as your vertical asymptotes would occur at pi halves plus n pi, as you're going up pi amount, right? But where where n can be any integer, or n can be any integers. If you want to generalize, that sequence there, or that set of vertical asymptotes, right? For example, if n is 0, right, you have pi halves plus 0 times pi, which is just pi halves, right? And then if your n is, let's say it's 1, right, pi halves plus 1 pi would be 3 pi halves. If your n is 2, pi halves plus 2 pi would be 5 pi halves, and so on. Then if you want to go in that negative direction, pi halves minus pi would be negative pi halves, right, if n is negative 1, and so on. So you notice that it hits each and every one of those vertical asymptotes when you let n be an integer, okay? So let's put those vertical asymptotes on there. So the first one was x equals pi halves, okay? So you're going to be undefined there. Next one is x equals 3 pi halves, right? You're going to be undefined there. 5 pi halves, so on. Let's go negative pi halves, negative 3 pi halves, negative 5 pi halves, and so on, okay? So now let's look on the graph here between negative pi halves and pi halves. And you're like, well, what's the behavior here? Let's pick something between, how about between, we know the point 0, 0 is on there, right? So let's pick something between 0 and pi halves, like pi fourths. Let's pick pi fourths, okay? So what's the sine at pi fourths? I say, well, that's root 2 over 2, right? And what's the cosine at pi fourths? That's root 2 over 2. So if you're figuring out, I'll write that down, the tangent of pi fourths, which is sine of pi fourths over the cosine of pi fourths, you say, hey, that's 1, right? So we have the point pi fourths, comma 1, okay? Pi fourths, comma 1. And then you're like, well, you can get some more. How about negative pi fourths? Plug in negative pi fourths, you're going to end up with negative 1, okay? Pi fourths, negative 1, okay? And you could go with, maybe you could go with pi 6 because that's on the unit circle. That's between 0 and pi fourths as well. Okay, so pi 6 is about, about right there. So there's pi 6. This one was pi fourths. Of course, you got pi thirds. That could be another one here. Pi thirds about right there. Okay. So anyways, we plug in pi 6. And we go, well, the sine at pi 6 is a half. The cosine at pi 6 is root 3 over 2. And then we rationalize that. And we get 1 over root 3, or root 3 over 3. And you'd punch that into your calculator and get the decimal for root 3 over 3, which is, punch that in, 0.577. Okay, 0.577. Pi 6, 0.577. You punch in, like pi thirds. Get 1.732. Or in other words, root 3 over 2 over 1 half. This is sine over the cosine again, right? Which is root 3. 1.732. And so on. Okay, anyways, you get a bunch of these, and soon enough you see that your tangent function, you got this vertical asymptote. So as you approach this pi halves, what does the function do? Shoots up, just like a vertical asymptote would you would expect it to behave, right? As you approach negative pi halves from the left there, it shoots down, and you got that vertical asymptote. Okay, you can punch in a bunch of these, and you say, oh, looks like, sine of pi over the cosine of pi. Sine of pi is 0, cosine of pi negative 1, 0 over negative 1 is 0. Anyways, you get a bunch of these, and you see that this thing starts repeating this pattern here. The tangent function repeats this. Okay. All right, so there's our tangent function. Okay. So let's talk about, what's your period here? Move this down a little bit. What's the period of this function? This is obviously cyclical. The period here, do you notice that it repeats that pattern each time, doesn't it? Between those vertical asymptotes. See how it repeats it? How long does it take to repeat it? Well, what's pi halves minus a negative pi halves? Pi halves minus a negative pi halves, you find the difference there is pi, right? Every pi amount, it repeats this pattern. Okay, so your period here is pi. Your domain, x, such that, and you say, well, x can be anything except those vertical asymptotes, right? So I'm going to state that generally. So x cannot be pi halves plus n pi, where n is an integer. Okay, and that will say it's everything except for my vertical asymptotes. Okay, that's a little technical. And then you say, well, what about my range? How low does this thing go? It keeps going down further, 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 right? And if you look at it, how high does this thing? Well, it keeps going higher, higher, higher. So your range here is going to be all round numbers. Got no restrictions on your set of y values. Okay. And then one more thing. How about, is this thing even or odd? Do you remember if the tangent is even or odd? Well, let's look at it. Let's look at this point here. This is kind of the giveaway. You guys see how you got pi fourths comma 1 right there? And then if you go in the negative direction, that same distance, so negative pi fourths, and it was the opposite, negative 1. In other words, f of negative x was negative f of x, which satisfies odd. Okay, so this tangent function is odd because of that test right there. F of negative x will equal negative f of x. Okay? Now what if we have some variations, some slight variations of this? Let's go with tangent, let's go tangent x over 4 here. Let's sketch tangent x over 4. And again, recall, this is sine of x over 4 over cosine, right? You say, well, let me think about my vertical asymptotes. Where is this thing going to be undefined? Where is cosine of x over 4 undefined? And I say, well, the cosine of what is 0? And I say, well, I know that the cosine of pi halves is 0, right? That's true. So what x value causes x over 4? Where does x over 4 equal pi halves, right? What causes that thing to be true? I say, well, that what is going to occur at 2 pi, right? Where would the next one occur? I say, well, I do know that the cosine of 3 pi halves is going to be 0, right? So when does x over 4 equal 3 pi halves, right? And I solve that. I say, oh, 12 pi halves, or 6, oops, I'm sorry, pi, okay? And then where's the next one? I say, well, 5 pi halves. When does x over 4 equal 5 pi halves? Let's solve that, right? You probably see the pattern here. 10 pi, okay? So it goes from 2 pi to 6 pi to 10 pi. You know, what's the difference there? You know, and I'm just going in the positive direction here. 2 pi to 6 pi to 10 pi, and you're like, oh, it goes up 4 pi each time, okay? It goes up 4 pi each time. So when you're graphing this thing, let me extend this a little bit. Let me let that be 2 pi. So I'm going to go up by 2 pi amount each time. So 4 pi, that'd be 6 pi, right? I got my vertical asymptote, 6 pi, 8 pi, 10 pi, another vertical asymptote, right? Of course over here, and we didn't do one on the negative direction, but we do know that the cosine of negative pi halves is 0, right? So when does x over 4 equal negative pi halves? And we're like, oh yeah, same thing. Oh yeah, as we expected, whoops, there's 2, negative 2 pi, right? So at negative 2 pi, as we were suspecting from this behavior, you have a vertical asymptote. Of course, the next one is going to be negative 4 pi, so on. Let me erase this here. 4 pi, so negative 6 pi, our next one, and so on, okay? So we got our vertical asymptotes here. So I'm like, well, now we gotta get some points here as well. Extend this a little bit. So let's plug in 0. Alright, so if we can get one of these periods, you know, between negative 2 pi and 2 pi, we know what this thing's going to behave like, because the parent function is tangent of x. Okay, so let's plug in 0. So again, tangent x over 4. So what's the sine? Plugging in 0. We're like, well, the sine of 0 is 0. Cosine at 0 is 1. Oops. So we got 0. 0 comma 0. How about the next one? You know, let's pick, how about right in between them? How about pi? So tangent of pi over 4. So I say, well, what's the sine pi fourths? What's the cosine pi fourths? That's sine pi fourths root 2 over 2, cosine root 2 over 2, and I'm like, oh, that's 1, right? So when I plugged in, what did we plug in initially? We plugged in pi, right? We solve that down and we get 1. So pi, comma, 1. Okay, negative pi. If I plug in negative pi, this is going to end up being negative 1 because this will be sine of tangent. I'm plugging in x, x being negative pi. So what's the sine at negative pi force over the cosine negative pi force? I see, oh yeah, that's negative root 2 over 2. Cosine there's root 2 over 2. So negative 1, so that's how you got that negative 1 there, all right? And so on. You can plug some more points in, but soon enough you're like, oh yeah, that tangent x over 4, you kind of see that. Now, granted, this is kind of, that x over 4, that 1/4 x in front of that, that thing is gonna shrink this thing, okay? Do you notice that your period, you've really stretched this period, how far is that? Well, what's the difference between negative 2 pi and 2 pi? 4 pi, right? So you've got this period now that's not just pi anymore, it's 4 pi. Your period here is 4 pi on this one, okay? Let me go back up here. And all of these, so it's cyclical, and you could check a bunch of other points here, right? A bunch of other points, but anyway, so that's what that 1/4 does on that. Changes that period, and so on. Now remember, this is a sketch, and I'm going by 2 pi each time, not pi halves, right? So it's going to look a little different. If you were to graph this on your calculator, you're going to see a lot of change there if you do it under the zoom trig feature, okay? Now let's go ahead and name your domain here. Your domain. So you're like, well, x such that x can be anything except, and now let's think about that. You know how the vertical asymptote is 2 pi, and then it went up to 6 pi, and so on. So I could say, you know what, it's just, why don't we just say it this way? We could also be a little lazy on this. Plus minus 2 pi, plus minus 6 pi, plus minus 10 pi, dot, dot, dot. Okay? Or if you want, you can generalize that formula. Okay, you notice that the difference there is 6 pi, just like we did on that last one. Your range here, your range is, it could be anything, and so on. Okay, of course this one's also odd function. Okay, so you kind of get that.